Hello everybody, this is part 1 of Solving Linear Equations series. Today specifically we are going to be solving simple equations, and the book that I'm going to be using is Big Ideas Math, Algebra 1. So let's go ahead and get started. So let's first go ahead and talk about one of the two properties when solving simple equations, the first being the addition property of equality. What this equality states is that you can have A being equals to B, but if you decide to add C, which is another integer, you must add it on both sides of the equal sign. When you do that, and you add C on both sides, you'll end up with an equation which is equal on both sides. So A plus C will be equal to B plus C. The subtraction property of equality almost says the exact same thing, except instead of adding on both sides of the equal sign, we are going to be subtracting on both sides of the equal sign. I would like to point emphasis towards the word equality, where we are just trying to create equations which are equal to each other. And the way that we do that is we do the same adding and subtracting on both sides of the equal sign. All of these different equations we have created, they're all equal to each other. All right, so let's jump in right into an example. So here's our first example, x minus 3 is equal to negative 5. So how are we going to approach this question? What we want to do is we want to isolate x. Our main goal when we see a question like this is to make x independent. And how can we make x independent in this question? We have to get rid of that negative 3. So what we can do is we can add 3 to both sides. That means negative 3 plus 3 is just equals to plus 0. Remember, we associate the sign, which is in front of the number. So we end up with plus 0. We bring the x down, so we have x plus 0. Bring the equal sign down as well. So we have x plus 0 equals negative 5 plus 3, which is just negative 2. However, we have that plus 0, but we know adding 0 to anything doesn't give it any meaning. So in other words, plus 0 means nothing. So now we have our final equation, x is equal to negative 2. So we have solved for the variable. How do we know that we got the right answer? Well, we can always do a check. So we just plug in negative 2 as x in our original equation, and we should get negative 5 is equal to negative 5. Let's go ahead and do example 2. This one is similar. It is just involving decimals. So we do the same process. We're trying to make y independent. So we subtract 2.8 from both sides, and we end up having negative 1.9 is equal to y plus 0. Now, plus 0 means nothing, so the answer is just y is equal to negative 1.9. Again, we're going to box our answer, and we can also do a check again. So we just plug in negative 1.9 into our original equation. Once we do that, we get 0.9 is equal to 0.9. So we know that our answer was correct. Let's go to our third example. Here we want to make p independent. So what we do is we subtract 3.9 from both sides. When we do that, we see that positive 3.9 minus 3.9 just gives us 0, which is exactly what we wanted. We bring the p down, we bring the equal sign down, and now we say negative 6.5 minus 3.9, which is negative 10.4. Again, the plus 0 means nothing, so p is just equal to negative 10.4. And we can go ahead and box that. We can also do a check just to make sure that our value of p is correct. So we just plug in p back into the original equation. Our main goal, again, is just to make the variable independent and on one side of the equal sign. So now we have two more properties. We have the multiplication property of equality and also the division property of equality. Again, we're just trying to create an equal equation. So if A is equal to B, you have to multiply C to both sides of the equal sign. Once you do that, you end up with an expression A times C is equal to B times C. Same goes for the division property of equality. You divide C on both sides, you end up with A over C is equals to B over C. So everything must be equal. What is done on one side of the equal sign must be done on the other. Okay, let's go to example 4. So this is a little bit tricky. What we need to notice is that we are dividing in this question. And we still have the same goal. We have to make n, our variable, independent. As a little side note, 1 over n times n is equals to n over n, which is just equal to 1. Like n over n is equals to 1, 5 over 5 is equal to 1. For in this question, we're going to multiply both sides by 5 to get rid of the 5 denominator. Once we do that, or another way to look at it is 5 times negative n over 5. And those 5 cancel because 5 divided by 5 is just 1. So we're left with just negative n on the left side. And then we do negative 3 times 5, which is negative 15. So we get negative n is equal to negative 15. However, n is not independent. It's not alone. It has a negative sign in front of it. So we can just say, since both sides are negative, we can just say n is equal to 15. How did we get that? Since there's 2 negatives on both sides of the equal, I can just go ahead and make them positive. Further explanation is what I did was when I made those 2 signs positive, I am essentially dividing both sides of the equal sign by a negative 1. And I have to emphasize both sides. Anything you do, any operation you do has to be done to both sides of the equal sign. Let's look at this question, pi x is equals to negative 2 pi. You might look at this and say there's 2 variables in this one. We have pi and x. And pi is a variable, but we know what the value of pi is. We know what it stands for. It stands for 3.14, some really long number. But what we are really trying to find is x. That's what we don't know. We're always finding what we don't know. And in this case, we don't know x. So to make x alone, we're just going to divide pi on both sides of the equal sign. So pi over pi is just equals to 1. And that's on both sides. So our pi just canceled out, which is perfect. So we just have x is equals to negative 2. I'm just here rewriting that pi over pi is equals to 1, just to understand. So 3.14 divided by 3.14 is equal to 1. And our final answer is x is equal to negative 2. And we can go ahead and box that. All right, so let's go ahead and look at our next example. So this is example 6. Now this one looks a little bit tricky, and sometimes just how the problem is written can really make things tricky for us. So just know that that is a division sign, which means we can just write it as a fraction. X over negative 2 equals 8. Our goal is the same, and that is to make x independent. How can we do that? We can multiply both sides by the denominator. So the denominator is negative 2. We can multiply both sides by negative 2. It gets rid of that negative 2 on the left side. So we end up with just x is equal to, again, negative 2 over negative 2 is equal to 1. So on the left side, we have x, which is independent, perfect. And we have 8 times negative 2. That means x is equal to negative 16. And we can go ahead and box that. Now let's go ahead and do our check. I didn't do it for the last problem, but let's go ahead and do it for this one. So what you do is you plug in x is equal to negative 16 into the original equation. So we end up getting negative 16 divided by a negative 2 is equal to 8, which means 16 over 2 is equal to 8. 8 is equals to 8. And yeah, we finished all these different examples. Hopefully all of this made sense. Feel free to rewatch any parts you don't understand and tune in for part 2. Thank you.